To show you how to do the video analysis kind of step by step here and what I want to have as a final product. So the first thing you want to do is go ahead and insert your movie and need to find out where that is. There's my movie, 18, and make the movie as big as you can make it. This is a little bit dark, but that's okay. And then you want to take this scroll bar and you want to move it, just click and drag and move it until you can see some motion in the ball as it's falling, right there, just like that, okay? So when I do that, I'm going to kind of go back up to where I can get a dot, and it's going to begin to move right after that. So I've got it set. Now I want to go right click on the movie, go to movie options, and we took this at 210 frames. So I need to change that override to the frame rate at 210 frames per second. I also want this dot to be the very first dot to start 0. So I'll click this where it says this is going to determine 0. And then I want to, because I used 210 frames a second, I want to go ahead and use a higher advance frame rate. So instead of having advance once, I'm going to have it advance 5 frames every time I add a new point. So got that set, and now I can do some other things for my movie. Here down in the bottom right, you'll see the breakout button. Go ahead and do that. You want to set your scale. Here we've got a meter stick, and we want to go ahead and measure that. Put it at the end of the meter stick. Click and hold. Click and drag to the other end of the meter stick. And that I know is 1 meter. And so that's what the default is. It comes up, and that's going to be 1 meter. So that's telling the computer that that's 1 meter of distance. And now I want to add a point. So I'm going to click on the red dot button right there, and I'm going to take my my cross, and I'm going to put it at the bottom of the ball, the bottom of the cross or the bottom of the ball. That pretty much puts me in the center of the ball. And it also allows me to stay out of the way, if you will. So I'll drop it. And then every time it's advancing 5 frames, it's also putting dots onto a graph. Now it's putting X and Y. So, and we're not going to worry about X. We're just, right now, we're worried about Y. And so as it's dropping, you should be able to see a little bit about what's happening here. It's getting faster and faster because with each increment of time, it's going further. And I just want to go down as far as I can go to get some good data. And the data you collect is only as careful as you are collecting it. And so that is going to be my last one, because the next one is going to bounce and hit back and bounce back, and I don't want that. So you can see that's a nice nice trail there. So you can do one of two things. You can go Control R, or you can go to Page and Auto Arrange. Both do the same thing. So now the video is kind of out of the way. Here's your data down here, video, and here's your graph. So now what you want to do is use this as your original graph. Left click over here on the y-axis, and then go to More. And what this does, this shows you what you have plotted. I don't want my X. Get rid of that, so just unclick that, uncheck that. And now I've got my Y. So this is my Y displacement. Right click, Graph Options, and put your title in. This is going to be vertical displacement. P displacement versus time of a falling ball, just to be more specific. And there you go. So now you got your title. You've got over here, you've got your Y values. You can even call this vertical displacement. You can rename that if you'd like, but Y is fine for this case. Okay? So there's your data. And now what you want to do is add a page. Come up here, add a page, or to page, add a page. Now you want to go ahead and copy this current page and hit click. And so now you're on page 2. So up here at the top, you can see page 2. Page 1 has got your dots on the graph or the video, and page 2 does not. So Now what you want to do is we want to get the equation of this line. So to get the equation of this line, we're going to click and drag. We're going to select all that data. And then we're going to come up here to the top just above it. And this is a function, so it's a curve fit. What we want to do is do a curve fit. Since this looks to be like a quadratic fit, let's go ahead and try that. So we'll hit quadratic, curve fit, try fit. And you can see that it's a nice fit. Here are all your parameters right there. This gives you an equation, y is equal to ax squared plus bx plus c, where in this case time is x, so t is time for x in this case. And so we'll hit OK. Now click and drag and just pull that guy out of the way a little bit, okay? Now the distance, or the equation here for this particular function is y is equal to negative 5.5 x squared. That's the equation of the line. We're not interested in B and C right now. So I'm going to go ahead and hit Insert Text Annotation. And you can see this little box creeps up. So now what you just want to say is that the equation for the line is y equals negative 5.5 t squared, and use the little caret for the square. Okay? And so what this really is showing us then is the equation here, d is equal to 1/2 at squared. So you can see then that negative 5.5 is equal to 1/2 the acceleration. So that's, which is not bad actually. So now I'm going to just take this, I'm going to click and drag this thing. I'm going to click and drag this thing and just put it over here somewhere. Now you can take the other end and you can just point to wherever you want to. So there you go. So now that explains what all this is. Okay? So now I want to add another page because I'm done with that. Now I want to add another page, so I'll go to Page, Add a Page. I can copy this current page if I'd like, which I can. And so now I don't need all this, so just exit. And this guy you can just delete. Uh-oh. Deleted the whole thing. Control Z brings it back. I just want to get rid of this box right there. I should be able to delete it, which I should be able to delete it. Nope, did that again. Why can't I just delete this annotation? Let me come over here. Maybe if I right click, text annotation, and well, you know what? We're going to leave it. Okay. Now I'm going to show you how to fix this. So now what I want to do is do my velocity, my y velocity. So I'm going to come down here and click y velocity. And there is my y velocity. Ooh, that's an interesting looking graph, but that's okay. So actually I'm not going to worry about this data right there because it's kind of funky. So I'm going to take from here on down to about right there. That's my y data that I want to take. I want to take the slope of this line, and that's not bad. So the slope of that line is pretty good. This now I'm going to change my title, right click, graph options. This is now the vertical velocity. Versus time of a falling ball. Okay, there you go. Uh-oh. And get rid of that little guy there. Okay, so now the slope of this velocity divided by time, change of velocity over time, is the acceleration. So now what I can do, I can just kind of highlight all that, get rid of that, start over with my text annotation and say that the slope of the line of the velocity CITY versus time is acceleration. I'm going to bring this guy over, move him so that he's kind of, there we go. Okay, is acceleration. And so now I know that the slope is equal to negative, it's a negative slope as you can see, 11, that's nice, 11.00 meters per second, and that's going to be squared, showing then the acceleration of the ball is negative 11.00 meters per second squared. Okay, done. And so you've got that. That looks good. So the slope of that line shows the acceleration. Okay, now I'm going to come back here to my first guide, so I can add a page, and I'm going to add a page here. And now, so this gives you some options after the current page, before the current page. You'll be able to change those, so I'm going to put it after the current page. That's not what I wanted. So I will go to add a page, copy current page, there, okay? Now I want to do the same thing in terms of my y velocity. Need to change, I can double click also, you can double click on the title and it pops up. So vertical velocity versus time of a falling ball. And I want to get the slope of the line here. So kind of take the same points. And instead of taking the slope of the line, what I'm going to do is take the area under the curve. And so that area under the curve gives me that shape and that area. I'm going to pull this up over here kind of out of the way. Now, since this is a negative, what I want to do is adjust this so it looks a little bit nicer. So I'm going to come up here, and I'm actually, if you click up here somewhere around the number on the y or x axis, you can change the scale. So I'm going to put this as from -2 to 5. So it gives me the idea, aha, well there's 0. And so it just makes it look a little bit nicer, a little bit more to kind of deal with. So the area under the curve here is actually the distance traveled. It's the distance traveled because it's velocity times time. And you can see that that's seconds times meters per second. So that gives us distance. So now I'm going to go ahead and insert my text annotation, and the area under the curve, although it's above the curve, represents the displacement of the ball. So the area under the curve, what happened to my cursor here? Nope. Area under the curve is equal to negative 2.1, we'll say, meters. So the ball fell 2.1 meters. Bang, there you go. Okay, and then you can take this thing, stop double clicking, and pull him there, and we can just kind of do that there. All right, so again, just trying to get to show all these things. And now I want to add another column. So I want to add another calculated column because I want to do acceleration. So I'm going to come up here to Data, click that, New Calculated Column, and I want this column to be labeled Acceleration. The short name can just be ACCEL for acceleration. The units are meters per second caret squared. And so the function, so the second derivative is what this is essentially, is that we're taking the distance and dividing it by time. Okay, so we're not doing the graph yet. We're trying to get the column, and then we'll come back and do the graph. So the function, we're going to come up here to calculus. We're going to take the second derivative, and then we're going to take the second derivative of the distance, which is y, and then done. And what that does is that puts into another column the acceleration. Okay, and it's kind of all over the place, but we'll deal with that. So coming up here to the velocity graph, to the y axis, we're going to find acceleration is now listed as one of those that we can plot. So we're going to plot acceleration. We're going to come up here, double click on the title, and acceleration versus time of a falling ball. And that doesn't even look, it should be a straight horizontal line. It doesn't even look like it. So what I need to do is back out. And I'm going to back out. I'm going to go to -50 for the bottom. And to the top, I'm going to go 10. So now you can see, it kind of looks like a straight line. Kind of looks like a straight line. And so if I were to do it right along in here, you could see there's a best fit line right there. These, remember, in the other ones, we didn't take these on the outliers. So I'm going to take from here to about, didn't mean to do that, from here to about there, and see what my slope is going to be. Now, that's not too bad. That's not too bad. Okay, so I'm just going to leave that and do some interpretation. So what this interpretation is, I can get rid of this. So the interpretation is that the acceleration was a constant acceleration, but because of the data and the way that I collected it and the way that I clicked my points, I have some things all over the place. But you can see the idea. You can see if you back far enough away, that's going to be the data is along some horizontal line there of some best fit line. And that's what you see. The y-intercept is where we want this to be, the y-intercept. In fact, if I pull this guy out, you can actually take this, and that's even better. I like that. I'm going to do that. So there's my data. So now you see what happened to the line. It became a bit more horizontal. The y-intercept is where the acceleration is going to be placed. So the acceleration is shown to be a constant, which it should be. It's supposed to be -9.8 meters per second squared, but and in this case a constant value. The y-intercept is or represents the value for the acceleration. All right, so that's done. And so we can come up here like this and kind of point that to the y-intercept. All right. Now, I'm not going to do the next one, which is the area under the curve of this guy. The area under the curve of the acceleration graph represents the final velocity, but I'm not going to attempt to do that because it's not going to work out the way we want it to because of the data. But anyway, that's how you need to get all this organized, and you should then be able to look at some page options. I think you can move these pages around and put them in order. But you know what? I'm going to let you figure that out. Okay? So, there you go. And, well, good luck.